Right. One minute. So here we will see about the nanomaterials here. 1 minute. Okay. So is it audible? Any one of you? Okay. Right. So we'll see about nanomaterial. What is a nanomaterial? We will see, and then we'll move to different types of classification and all those things we'll see here. So next slide, we'll move next slide. Right. So 1 minute. So here, as we know that nanomaterials, so nanomaterial is nothing but the size of this material, which is going to be very small, which we have very smaller in size. So we will be studying about that nanomaterials here. So nanomaterials, uh, so nanomaterials plays a crucial role in the field of nanoscience and nanotechnology. So the study of nanostructure will gives what we call the study of nanostructure and science and nanostructure science and technology is a broad and interdisciplinary area of research and development. So as we have seen that these nanomaterials are plays a crucial role in the fields of nanoscience as well as the nanotechnology. And as we said that this nanostructures science and technology is a broad and interdisciplinary area. That means it can be utilized in all the fields it is utilized. So it is a very broad and interdisciplinary area in the case of the research and as well as the development activity that has been growing explosively in the worldwide in the past few years. Okay. So it has potential for revolutionizing the ways in which materials and products are created and the range and nature of functionalities that can be accessed. So it is already having significant what we call a commercial impact. That means commercially we are using this nano materials, so which all increases in the future. Okay, in the coming future, the commerciality of this nanotechnology is going to be very much increased in every field, not only in the research field, but in our daily life, we are going to be use these what we call nano materials. We are going to be used. Already we are in using these nanomaterials, but in future it is more we are going to be use these nanomaterials. Okay, so that is what we are nowadays. We are use nano or technology research as a nanoscience research has been significantly increased, and in coming years it is going to be more and more. You are going to be get here in the coming future. So that is about introduction of this nanomaterials which we have. And if you see, what actually nanomaterials means, okay. So nanomaterials, if you take these nanomaterials are what we call are substances that have at least one dimension, which is less than approximately 100 nanometers. Okay. So the nanoscale materials, which are defined as a set of substances where at least one dimension is less than what we call 100 nanometers you are going to be have. Those we will be calling it as a nanomaterials we are going to be called here. Right. So this is what the definition of the nanomaterials we have. And if you take this a nanometer, so a nanometer is nothing but it is 1 millionth of a millimeter. Approximately, if you take the size of the this is 10,000 times smaller than the diameter of a human hair. That is the smallest size which we have for what we call nano materials. Okay, 1 minute. So, nano scale materials already we have defined about the nanomaterial scale we have defined. It is a set of substances where at least one dimension is less than 100 nanometers it should have. That is what a materials we can define. So a nanometer is nothing but it is 1 millionth of a millimeter, which is approximately or 1 lakh times smaller than the diameter of a human hair it is going to be have. So that is the size of the nanometer which we have. And if you see these nanomaterials are of interest because of at this scale you have like a unique optical properties, magnetic properties, electrical properties, and other properties it is going to be have. So at this size of the material, it is behaving what we call it is having unique properties. The properties which we have unique properties are optical properties, magnetic properties, as well as the electrical and other properties. It is going to be have unique. That means that if you take that smaller in size of a material, its behavior is unique. You are going to be have. Okay, so these emerging properties, whichever we have, so these emerging properties have the potential for great impacts in in the different fields. Otherwise, significant fields, whichever we have, like electronics, medicine, and other fields. Okay, so the properties, whichever we have seen, like the optical properties or magnetic properties or electrical properties or other properties, whichever we have. So these properties could have a significant impact in electronics as well as the medicine, electronics as well as the medicine, and all those things. It is having a significant impact. So that is the reason why see these nano materials are very much used in nowadays, as we are having so much research is going on in these days. Okay, so that is the properties which we have, very good properties we have. Okay, and if you take these nanomaterials, where we are going to be found these. Okay, so these nanomaterials where we are going to be found, we'll see here. So some nanomaterials, they occur naturally, but of a particular interest, that means if you want to use these nanomaterials in any particular field, if you want to use, so then what we have to do is we have to be make these nanomaterials. That means we have to engineer these nanomaterials, okay, for a particular interest, or engineered nanomaterials, so which are designed for what we call designed for and already being used in many commercial products and processes they are using. So they can be found in such things as these nanomaterials nowadays in daily life, where we are using means in sunscreens we are using these nanomaterials, and as well as the in cosmetics and sports goods, where we are using, as well as the stain resistant clothing, we are using these nanomaterials, and as well as the tires, these nanomaterials we are using, as well as in the case of the electronic items we are using these. Okay, as well as many other everyday items we are using these nanomaterials. And if you go for in the case of the medicine, where we are using means in the medicine for the purpose of diagnosis we are using, and as well as the in the case of the what we call imaging. Suppose if you want to get a good image, if you want to get, that means the internal organs of any human body, if you want to get clear what we call a clear clarity of that image, if you image of any organ if you want, then there we are using these what we call nanomaterials we are going to be used. And is in the case of the drug delivery also, we are using these nanomaterials. And these engineered nanomaterials whichever we have, so engineered nanomaterials, a minute. Right. So these engineered nanomaterials are resources designed at the molecular, that means at the nanometer level, to take advantage of their small size and the novel properties which are generally not seen in their conventional and bulk counterparts. Okay. So at the nano level, all these are going to be available, and whereas in the case of the bulk means the size whichever we have larger in size, we won't find these. So that is these engineered nanomaterials are resources designed at the molecular, that is at nano meter level, to take advantages of smaller in size. Okay, so which are not available in the case of the bulk counterparts. The two main reasons why materials at the nano scale can have different properties are because of increased relative surface area, and new quantum effects. So these are the two main reasons why these nanomaterials at the nanoscale can have the different properties, whichever we have said that unique properties are because of increased relative surface area and new quantum effects. So the nanomaterials have a much greater surface area to volume ratio than the conventional forms. Okay. So the nanomaterials have much greater surface area. So this is one part which we have. They have the what we call greater surface area they have. 1 minute. So they have a what we call a greater surface area, greater surface area to volume ratio than the conventional forms, which can lead to greater chemical reactivity and affect their strength. Okay, so one of the reason why we have is increased relative surface area, and it is having some what we call new quantum effects. Is having a new quantum effects. So these are the two main reasons why materials at the nanoscale can have different properties uh, as what we call increased relative surface area and the new quantum effects. Okay, so nanomaterials have much greater surface area to volume ratio than their conventional forms. Conventional form means which are having the uh, larger in size. And if you take so also these at the nanoscale, the quantum effects can become much more important in determining the material properties and characteristics, which leads to what we call novel optical, electrical, and magnetic behaviors, which leads to novel electrical as well as the optical and magnetic behaviors. Okay, so these nanomaterials, if you see they are already in commercial use. They are already in commercial use, with some having what we call with some having been available for several years or decades. Already from the decades, like some 10 to 15 years before the commercial usage of what we call these nanomaterials has been more we have. The range of commercial products which are available today is very broad, which is including as already we said that like we have a what we call a stain resistant and wrinkle free textiles we have. So already we are using these stain resistance and wrinkle free textiles we are using. And in the case of the cosmetics, also we are using these nano materials we are using. And in the case of the sunscreens we are using these nanomaterials, and as well as in the case of the electronics, we are using these nanomaterials, and paints as well as the varnishes, we are using these nanomaterials. Already we know that some paints which are available in the market, they are what we call dust-free paints. We are calling dust-free paints means even though if dust is falling on the wall, so it is going to be it will not stays on the wall because of there we are using this nano materials, so which does not allow the dust particle onto the paint. So that is what we have the application like in the case of the paints and as well as the varnishes we are having. And these nano coatings, if you take these nano coatings and nano composites are finding uses. These nano coatings and nano composites are finding uses in diverse consumer products, which we have like windows, sports equipment we are using, and as well as in the case of the bicycles and the automobiles also we are using. Okay, so these So there are what we call novel UV blocking coatings on glass bottles we have, which protects beverages from damage by sunlight, and longer lasting tennis balls we have using this what we call butyl rubber and nano clay composites we are using. So nanoscale, what we call titanium dioxide, for instance, is finding applications in cosmetics, sunblock creams which we are using. That means sunscreen lotions which we are using, and also self-cleaning windows. Self-cleaning windows is nothing but they are not going to be allow the dust particle to be formed there. Okay. And nano scale silica is being used as a filler in range of products, including cosmetics and as well as the dental fillings. Dental fillings means where we are using this in dentist, these are using. So in that case, we are using this nano particles we are using. Okay. So if you see the advances of nanomaterials, so advances of nanomaterials, that means from where the nanomaterials has been started and from which year we are using these nanomaterials. If you see, as we said that the history of nanomaterials began immediately after the what we call Big Bang, when nanostructure were found in the early materials. Okay, so nature later evolved many other nanostructures like seashells as well as the skeletons, etc. So nanoscales smoke particles were found. Nanoscale smoke particles were found. 1 minute. So it is already, we had some problem with the net. So as I told that, as we have discussed scientifically, what we call uh, which we have given certain report by Michael Faraday in the early what we call 1857. So nanostructured catalysis have been also these catalysis also investigated for over 70 years. In the early 1940s, they have found silica nanoparticles are being manufactured, and they have sold in what we call in the country USA and Germany as a substitute for what we call ultra fine carbon black for rubber reinforcements. So that is what they have started this. There's nano-sized amorphous silica particles have found large-scale applications in many everyday consumer products, ranging from non-dairy coffee, creamer to automobile tires, as well as the optical fibers and catalysis supports. Okay, so in the early 1960s, and the 1970s, metallic nano powder for magnetic recording tapes were developed. In the early 1960s as well as the 1970s, this has been what we call developed this powder, that is magnetic recording tapes were developed. Okay. So in the year 1976, for the first time, nanocrystals produced by the uh, popular inert gas evaporation technique was published by some scientists. Okay. So recently it has been found that what we call the Maya blue paint is a nanostructured hybrid material. So like this, the nanomaterials has been advanced. That means they have been invented. So the origin of its color and its resistance to acids and what we call biocorrosion are still not understood, but studies of authentic samples from different islands shows that materials is made up of needle-shaped what we call needle-shaped crystals that form a superlattice with a what we call period of 1.4 nanometers. That is very smaller in size. So with which interacts of amorphous silicate substrate containing inclusion of metals, nanoparticles we have. Okay. So then the blue color, which is obtained only when both these nanoparticles and superlattice are present, as has been showed by the fabrication of synthetic samples. So today, this nanophase engineering expands in a rapidly growing number of structural and functional materials, both in the case of the what we call inorganic and as well as the organic. So which allowing to manipulate mechanical catalysis, electric, magnetic, optical, and as well as the electric functions. Okay. And as well as the, if you see the advancements of these nanoparticles, the production of what we call a nanophase materials is usually based upon the creation of separated small clusters, which then are fused into bulk-like materials. Okay. So examples for this we have is like a nanophase silicon, which differs from normal silicon. So generally we have the silicon, whereas the nanophase silicon, if you take, so that will be differs from the normal silicon in physical and electronic properties. So which could be applied to what we call macroscopic semiconductor processes to create new devices. So for instance, if you take when ordinary glass is doped with the quantized semiconductor collides, it becomes a high performance optical medium. Okay. So with potential application in optical computing. So like this, what we call the nano materials has been developed over years. So advancement of nanomaterials has been done here. So if you go for the classification of the nanomaterials, if you go, so these the nanomaterials have been uh, extremely smaller in size, which having at least one dimension, 100 nanometers. Already we have studied 100 nanometers or less than 100 nanometers you are going to be have. So these nanomaterials can be nanoscale in one dimension. Example, like in the surface films you have. So two dimensions we have examples as like fibers we have, and as well as the three-dimensional also we have like a particles. Okay, the particles we have. So zero dimensional as well as the what we call sorry, one dimensional as well as the two dimensional as well as the three dimensionals. So basing upon these one dimensional, two dimensional as well as the three dimensionals, they have been classified. So they can exist like if you take the three-dimensional one, they can exist in a single as well as if fused and aggregated forms with spherical shape or tubular shape and irregular shapes you may be having. Okay. So the common types of nanomaterials, which includes like nanotubes we have, quantum dots we have, and fullerenes we have. Okay. So nanomaterials have applications in the field of nanotechnology and displays different physical chemical characteristics from normal chemicals example, like a silver nano or a carbon nanotube, fullerene, as well as photocatalyst, carbon nano we have, like a silica we have. Okay, these are the certain examples which have the physical, chemical, what we call properties, physical as well as the chemical characteristics forms the nanochemicals. So here, if you go for like some according to certain Siegel nanostructured materials, they have been classified like a zero dimensional. We have a one dimensional. We have as well as the two dimensional and as well as the three dimensional nanostructures we have. So according to these scientists, so this is the what we call the picture figure we have the classification of the nanomaterials. So the first one is it is a zero dimensional spheres and clusters we have. So these are the zero dimensional spheres and as well as the clusters we have. And if you go for this one dimensional, so in the case of the one dimensionals, we have nanofibers, we have nano wires as well as the nano rods. So in the case of the one dimensional nanomaterials, if you take, so under these one dimensional nanomaterials, we will be getting nanofibers, nano wires, and as well as the nano rods, which we are going to be come here. So these are one-dimensional one which we have. And similarly, if you go for two-dimensional nanomaterials, if you take, so these are two-dimensional nanomaterials is like 2D films we have. Okay, 2D films we have, as well as the plates and networks we have. So under these, what we call classification of these nanomaterials. So then if you go for three-dimensional nanomaterials, so this is the three-dimensional nanomaterials which shown here. So these nanomaterials are materials which are characterized by an ultra fine grain size. Ultra fine grain size. So generally, the ultra fine grain size means which is having less than 50 nanometers. Okay, 50 nanometers. Or by a dimensional, which is or by the dimension of which is limited to 50 nanometers. Okay, nanomaterials are materials which are characterized by an ultra fine grain size, which is limited to 50 nanometers. Okay, so then if you move to these nanomaterials, the nanomaterials can be created with various modulations, various modulation dimensionalities, which are given by Siegel. So zero means which is comes under this is atomic clusters, filaments, and cluster assemblies we have. In the case of the this one-dimensional whichever we have, so we have the multi-layers we have. In the case of the two-dimensional one, we have ultra-fine grained layers, otherwise ultra-fine grained over layers we have, or buried layers we have. And in the case of the three-dimensional one, so these under these three-dimensional one, we will be getting this what we call nano phase materials consisting of equipped with nanometer sized grains. Okay, so as which is shown here in this figure. Okay, so why these nanomaterials are very important? If you see these nanomaterials, so what is the use or what is the importance which we have, whether it may be zero dimensional one or one dimensional or three dimensional, and whichever we have, what is the importance? Why so much importance is there? If you see, so these materials have created a high interest in the recent years. That means in the nowadays, these nanomaterials which we are using is very interest we are having. So why? Because by virtue of their unusual mechanical, electrical, as well as the optical and the magnetic properties. So if you compare the bulk size materials, whatever may be the properties which we have, like a mechanical, electrical, optical, and magnetic properties. So those properties in the case of the bulk size materials, and if you compare with the nano size materials, so these nano size materials, they are having unusual mechanical, electrical, optical, and as well as the magnetic properties it is having. So if you see some examples, which we have means unusual properties which you have. Suppose if you take a nanophase ceramic if you take. So these nanophase ceramics are of a particular interest because they are more ductile at elevated temperatures as compared to the what we call a grained ceramics. So that is one reason why we using why we have very much interest in the case of the nano size materials. And suppose if you take this another material of a nano size, so these nano structured semiconductors if you take, so these nano structured semiconductors are known to show various non-linear optical properties. It is going to be show various non-linear optical properties. So the semiconductor Q particles which show quantum confinement effects which may lead to spherical what we call special properties. So like what are the special properties which is showing in the case of these semiconductor Q particles is in the case of the luminescence in silicon powders and silicon germanium quantum dots as infrared optoelectronic devices. These are very important. Okay, so these nanostructured semiconductors are used as window layers in solar cells. So in the case of the solar cells also we are using this what we call nanostructured materials. So that is what very much importance we have nowadays. The solar power which we are generating is more we are generating nowadays. So there in the case of the what we call solar cells, we are using as a window layers we are using. So that is what very much interest has been shown in the case of these nanomaterials in these days. And if you take one more, this nano-sized metallic powders. Okay, if you take this what we call nano-sized metallic powders, they have been used for what we call for the production of gas-tight materials. So these nano-sized metallic powders have been used for production of gas-tight materials. So come in the case of the what we call dense parts and as well as the porous coatings, we are using these nano-sized metallic powders we are using. And also what we call cold welding properties combined with the ductility make them suitable for metal bonding, especially in the electronic industry. So that is what very importance we have in the case of the electronic industry. And if you take this single ion, what we call a single nano-sized magnetic particles, if you take, so these single nano-sized magnetic particles are mono domains, and one expects that also in magnetic nanophase materials, the grains correspond with domains. So while boundaries and the contrary disorders walls. So very small particles have special atomic structure with discrete what we call electronic states. So which gives rise to special properties in addition to the what we call a super paramagnetic behavior. So that is the reason why we are showing very much interest in the case of this what we call nanoparticles, nanomaterials. So similarly, if you take the magnetic nanocomposites, if you take these magnetic nanocomposites have been used for mechanical force transfer, which are using for a mechanical force transfer we are using for high density information storage and as well as the magnetic refrigeration. So in the case of the magnetic refrigeration and as well as the high density information storage. So nowadays, if you see these optical devices where we are storing the data, so the size, the storing the data size has been increased drastically. That means nowadays, one TB or 2 TB of data storage that is been taking in a smaller size. In a small size, we have that optical device in which we are storing like 1 TB or 2 TB, 3 TB data we are storing. That is due to the what we call this nano materials only it is possible. So that is the reason why we have very much interest in the case of this what we call nano materials. So if you take this nanostructured metal clusters, so these nanostructured metal clusters and as well as the colloids of mono or what we call mono or composition have a special impact in catalytic applications. In catalytic applications also these are very much usefulness we have. Okay. So and as well as the if you take the nanostructured metal oxides, thin films, so the nanostructured metal oxide thin films are receiving a good attention, or which is growing attention for the realization of the gas sensors. So gas sensors like CO, CO2, CH4, whichever we have. So with the enhanced sensitivity as well as the selectivity. So that is the reason why we are using much what we call these nano materials we are using. Okay, so like this, so in different places we are using this these nano materials. So if you see the examples of nano materials, if you see, so we have examples of nano materials. 1 minute before that. So nanomaterials like a gold or carbon, metals, meta-oxides and alloys which we have with a variety of morphologies. That means with the variety of structures we have. Okay. So as a nanoparticles means if you take very smaller in size, we have in the case of the fullerenes, if you take, we have different shape, as well as in the case of the nanosphere, if you take, we have the different structure we have. So like these nanomaterials with a variety of morphologies we have, like nano flowers we have, silver nanocubes we have, and as well as the what we call a titanium nanoflowers we have, and as well as the SNO2 nanoflowers we have. So different types of what we call shapes or we are having in the case of these nanomaterials. So if you see the classification or if you see this carbon and nanocarbon materials, so we have carbon and non-carbon nanomaterials we have. Okay. So 1 minute. This carbon and non-carbon nanomaterials if you take, so the materials which are referred to as nanomaterials, the materials which are referring as nanomaterials, they are generally fall into two categories. One is fullerenes we have, and another one is inorganic nanoparticles we have. One is a fullerene, and another one is having the what we call inorganic nanoparticles we are going to be have. So if you go for the fullerenes, what is a fullerene if you take? So the fullerene is a class of allotropes of carbon which are graphene sheets and rolled into tubes or hollow spheres. Okay. Spherical fullerenes are also called buckyballs, and cylindrical one are called as a carbon nanotubes or buck tubes we are calling. So similarly, fullerene are similar in structure to graphite. So these fullerenes are having similar structures to graphite we have, but they may contain what we call pentagonal rings, carbon nanotubes or allotropes they are having. So carbon with cylindrical nanostructure also we are having. So that is about the fullerenes. And if you go for what we call inorganic uh, nanomaterials. So these inorganic nanomaterials, generally they are having the size, otherwise the dimension of this inorganic nanomaterials if we take. So they are in between like 1 and 100 nanometers they are having. So the size are the inorganic nanomaterials size is in between the 1 nanometer to 100 nanometers they are having. Okay. So these 100 in between these 1 and 100 nanometers if we take, so they will be taking what we call different forms. They are going to be have different forms like clusters they have, and as well as the metal nanoparticles they have, as well as the colloids, as well as the nanocrystals, as well as the quantum dots we have. Okay, so different shapes whichever we have in between 1 to 100 nanometers you are having. Especially if you take this nano clusters, so these nano clusters have the dimensions between 1 and 100 nanometers, and they are having narrow size distribution they are having. And coming to these nanopowders, if you take, so these nanopowders are of nanoparticles or nanoclusters. These nanometer sized single crystals are single domain ultrafine particles are called nanocrystals. We are going to be called. Okay. So this is what about what we call uh, inorganic nanomaterials which we have. Okay. So then if you go for carbon nanotubes, so in the year 1990, the scientist Richard Smalley, uh, he was the first to give the concept of this vertical buckyballs get big enough, they can become carbon cylinders. Okay. So then after in the year 1991, in the year 1991, this scientist Sumio, he discovered these carbon cylinders. He discovered, and the carbon cylinders, whatever he has been discovered, he named it as a nanotubes. He has been named here. So this name is derived from the size. Okay, carbon nanotubes, whichever we have, it has been given from the size. So generally, if you take the size of this one, the length to what we call diameter ratio, the length to diameter ratio if you take, so it will be having what we call a greater than 1 lakh we are going to be have. So these nanotubes are formed at the same time when buckyballs are formed. So nanotubes are members of the fullerene structural family, which allows include the spherical buckyballs. Okay. So carbon nanotubes is a sheet of graphite rolled into a cylindrical structure in which one carbon atom is covalently bound to the three other carbon atoms. One is carbon atom is covalently bonded to three other carbon atoms. So like buckyballs, carbon nanotubes are each a lattice of carbon atom. Each atom is covalently bonded to other three carbon atoms. Like then basically these carbon nanotubes are buckyballs we have. Okay. So however, if you take their end can never closes into a sphere when they are formed. So instead of forming the shapes of a sphere, the lattice forms the shape of a what we call a cylinder we are going to be have. So if you see uh, the carbon nanotubes, so we have like a zigzag carbon nanotube. This is the zigzag nanocarbon tube we have, and this is a chiral carbon nanotube we have, and this one is armchair carbon nanotube we have. So these are the some shapes of these what we call carbon nanotubes. Okay. So in this first one we have is a graphene sheet which is rolled out. So then we have zigzag, then chiral, then we have this what we call armchair uh, shape we have. Okay. So these are the different shapes of this carbon nanotubes which we have. And if you take this carbon nanotubes, again, these carbon nanotubes has been classified into two types. They have been classified. One is classified it as a, one we call it as a single walled carbon nanotubes we are going to be called. And another one we will be calling it as a multi-walled carbon nanotubes we are going to be called. Okay. So one is a single walled carbon nanotube we have. Then another one which we have is a multi-walled carbon nanotube we have. Okay. So these are the two types of what we call carbon nanotubes. We have single-walled carbon nanotube. Another one is a multi-walled carbon nanotube. So if you see the figure, so in this figure, this is what we have, the single-walled carbon nanotube, whichever we have. And this one, whichever we have is a multi-walled carbon nanotube we have. So these are the two different types of what we call carbon nanotube. So coming to this single walled carbon nanotube. So this can be thought of a one atom thick layer of a graphite. Otherwise, we call it as a graphene. It is a single layer of graphene we have. So which is wrapped into seamless cylinder like this. Okay. So two halves of a fullerene molecules does the structure at both ends. At the both ends we have. So single wall nanotubes can be so this single walled nanotubes can be what we call throughout of as a fundamental cylindrical structure, and those from the building blocks of both multi-wall nanotubes. And the ordered arrays of a single wall nanotubes called here ropes we are going to be called. So the single wall nanotubes have a dimensions in between 1 nanometer to 5 nanometers we have. The dimension of this one will be 1 nanometers to 5 nanometers we have. And usually around more than 1 millimeter, 1 millimeter length they have. The length of this one is more than 1 millimeter they are having. So the single wall nanotubes can be considered as a long wrapped graphene sheets. The length of diameter ratio of single wall nanotubes is generally about 1000 we are having. So that they are called one-dimensional structure we are going to be called here. Okay, that is about single-walled carbon nanotube we have. Then we have like a multi-walled carbon nanotubes. So in this, instead of one carbon tube within the cylinder, we have a multiple layers of graphenes we have in this one. So this multi-walled carbon nanotube, which is consisting of multiple concentric nanotubes we are going to be have. Concentric nanotubes means like this. So here we have a this one center is same with the different vertical diameters. So like this with the different diameters. So it looks like a single cylinder, but at the inner end we have a different layer of different vertical diameter. So this is consisting of a multiple concentric nanotube cylinders they are having. That is, they're consisting of what we call multiple layers of graphite rolled themselves to form a tube shape. Okay. And if you take the multi-walled carbon nanotubes, they are having 2 to 50 tubes inside this one. 2 to 50 tubes you are going to be have. So the separation between the neighboring tubes is roughly equal to that between the layers in natural graphite, and they are having the size of what we call 0.34 to 0.36 nanometer size they are having. Okay, so this multi walled carbon nanotubes have inner diameter which is starting from 1.5 to 15 nanometers you are having, and the outer diameter is around 2.5 to 30 nanometers you are having. Okay, so usually if you take the length of this multi-walled carbon nanotubes, so the length of the multi-walled carbon nanotube is around 1 nanometer you are having. Okay, that is what we call length of the multi-walled carbon nanotube. So if you compare these single-walled carbon nanotube as well as the multi-walled carbon nanotube, so if you see, so if you take the single-walled, it's simply a single layer graphene. It is a simply a single layer graphene you are going to be having in the case of the single-walled carbon nanotube. So if you go for this multi-walled carbon nanotube, so this is a multiple layers you are going to be have. As we seen, this is only one layer we are going to be see here. In this case, inside we have layers and outside here like this. So different multi layers of graphite graphene you are going to be have in this case. So in the case of the single walled carbon nanotube, if you see, it requires a catalyst for synthesis. It requires a catalyst for synthesis. It is required. So here in the case of the multi-walled carbon nanotube, so it produced without catalyst. So here it is a without catalyst we can produce, whereas in the case of this single walled, we required what we call a catalyst for synthesis we required. So and if you take this single walled carbon nanotube, so bulk synthesis of this is difficult in this case. Whereas in the case of this multi-walled carbon nanotubes, the bulk synthesis can be easy here in this case. Okay. And if you see in this case, that is a single walled. more defection during the functionalization you are having, and in this case, less defection you are going to be having. But it is very difficult to improve in this case. And purity, if you talk about the purity of this one single-walled carbon nanotube, it is a poor purity you are going to be have. That means very less poor purity you are going to be have. In the case of this multi one, we have the high purity we have. Okay. And if you see the single wall, in the case of the accumulation of the body, so it is less accumulated, less accumulation in the body we have. In the case of this multi-walled carbon nanotube, we have the more accumulation in the body we have. So in the case of the single walled carbon nanotube, so it can be easily twistable we have. In the case of this, it is very difficult to twist in the case of the multi-walled carbon nanotube. Okay. So, and characterization and evaluation is very easy in this case. The characterization and evaluation is difficult in the case of the multi-layered carbon nanotube. So this is what we call, we have some comparisons of single-walled and as well as the multi-walled carbon nanotubes. So these are the types of carbon nanotubes which we have. So as we studied, so what is the nanomaterial we have studied? The nanomaterial is nothing but the size of this nanomaterial is in between what we call 1 to 100. 1 minute. The size, if you take, the size of this nanomaterial is from right. So the nanometer is nothing but which is having very smaller in size. Generally, the size is less than 100 nanometers we have. That is what we have seen about the nanomaterial which we have defined. And these are very much interest